This is not science fiction. For the very first time, something made by human hands has flown through the atmosphere of a star. In a very real way, we have touched the sun. This is the story of the Parker Solar Probe, a machine hurtling through space at over 430,000 miles per hour, surviving impossible heat and radiation, all to solve the deepest secrets of our star. And in doing so, we've come face to face with cosmic forces we're only just starting to understand. For more than a century, our sun has been holding on to a stubborn, baffling secret, a paradox that just doesn't seem to make sense. The surface of the sun, the part we see called the photosphere, burns at a blistering 10,000 degrees Fahrenheit. But its atmosphere, the corona, which stretches for millions of miles, somehow skyrockets to temperatures of 2 million degrees or more. So how in the world can the atmosphere be hundreds of times hotter than the thing that's heating it? It's like walking away from a campfire and feeling the air get warmer, not cooler. This is the coronal heating problem, and it has stumped generations of astrophysicists. Solving it was going to take more than just bigger telescopes. It required actually going there. The dream of sending a probe to the sun isn't new. It's a concept that's been on the drawing board for over 60 years. The whole adventure is built on the wild idea of a young astrophysicist named Eugene Parker. Back in 1958, he proposed something radical: that the sun doesn't just radiate heat and light, but constantly blows a stream of charged particles into space, a supersonic flow he called the solar wind. At the time, his theory was so out there that it was met with serious skepticism. But Parker was right. Early missions, like Mariner 2 in 1962, flew out and got the first direct measurements that proved his theory was real. This solar wind is part of what gives comets their sweeping tails and lights up our night sky with auroras. But it's also the source of dangerous space weather, solar storms that can knock out our satellites, fry power grids, and threaten astronauts. To understand it and predict it, we had to go to the source. But how do you build a machine that can survive a trip into the furnace of the solar system? For decades, the materials and technology simply didn't exist. The mission remained a tantalizing but impossible dream. That is, until a team of brilliant engineers at the Johns Hopkins Applied Physics Laboratory decided to take on the impossible. The result was the Parker Solar Probe, named in honor of the man who started it all. In a touching tribute, Eugene Parker, then in his 90s, was there to watch his namesake spacecraft leave the planet, the first person in history to see a mission named for them take flight. Launched in the pre-dawn hours of August 12, 2018, the Parker Solar Probe began a clever and intricate journey. You can't just fly straight at the sun. You'd be moving so fast you'd whip right past it. To get close, the probe had to hit the brakes on the incredible sideways speed it inherited from Earth's orbit. To pull this off, mission planners designed a patient cosmic ballet using the gravity of Venus. Over 7 years, the probe performed 7 Venus flybys. Each pass acted like a gravitational brake, tightening the probe's orbit and letting it fall closer and closer to the sun. With each pass, it dove deeper into the sun's gravity, accelerating to speeds that shattered all previous records. On its closest approaches, Parker Solar Probe hits a mind-boggling velocity of roughly 430,000 miles per hour. That's not just a number. It's fast enough to get from New York City to Tokyo in under a minute. It is, by a huge margin, the fastest object ever built by humanity. But speed is only half the challenge. The other is the heat. To survive these daring plunges, the probe hides behind a revolutionary piece of tech, the Thermal Protection System, or heat shield. It's a 4.5-inch thick shield made of carbon composite foam sandwiched between 2 carbon plates. But this thing is an engineering marvel. While the sun-facing side of the shield soaks up temperatures around 2,500 degrees Fahrenheit, the delicate instruments just behind it stay at a comfortable room temperature. The probe is also brilliantly autonomous. During its closest passes, the sun is so blindingly bright and the communication delay is so long that the probe has to protect itself. Its advanced software is constantly making tiny adjustments, keeping that heat shield perfectly aligned, like a frantic parasol holder in a hurricane of light. For years, the probe spiraled closer and closer. Then, on April 28, 2021, during its 8th orbit, it happened. Parker's solar probe crossed a critical line that scientists had only theorized about for decades, the Alvin critical surface. This isn't a solid line, but a wavy, shifting boundary that marks the outer edge of the sun's corona. It's the point of no return, where the solar wind is no longer magnetically tied to the sun and becomes an untethered blast into the solar system. For the first time, a spacecraft was flying through the sun's atmosphere, not just looking at it from afar. It spent 5 hours inside the corona, sampling particles and magnetic fields directly. Imagine the data flooding back to Earth. That was the moment humanity realized we'd done it. We had touched the sun. Since that initial crossing, the probe has dipped in and out of the corona many times, confirming the boundary isn't a smooth sphere, but is wrinkled and irregular. So, what have we learned from this wild ride? Parker's data is already rewriting the book on the sun. One of the most electrifying discoveries is about the nature of the solar wind itself. Before Parker, scientists had seen bizarre S-shaped kinks in the sun's magnetic field, which they called switchbacks. They were thought to be rare. Parker discovered they are everywhere near the sun, a wild ocean of magnetic flips. Data now suggests that many of them get their start near the sun's visible surface, in magnetic funnels between massive convection cells. Scientists are now in a heated debate about how these switchbacks form and whether the energy they release could be a key ingredient in heating the corona and kicking the solar wind into high gear. Parker is also giving us fresh clues to that big coronal heating mystery. While switchbacks were once a leading suspect, recent analysis shows they probably don't form deep enough in the corona to be the only explanation for its intense heat. Instead, other theories are gaining ground. And get this, new findings are even making scientists wonder if cosmic dust, something they used to think was irrelevant this close to the sun, might be playing a part by interacting with the plasma. The probe is handing scientists the puzzle pieces, even if the final picture isn't clear yet. It's the scientific process unfolding in real time, millions of miles from home. The Parker Solar Probe's journey is far from over. Its primary mission phase was completed in mid-2025, but the spacecraft is healthy and continues its work in an extended mission. After its final Venus flyby in late 2024, it settled into a record-breaking orbit. It is now repeatedly making passes just 3.8 million miles from the sun's surface, a record it first set in December 2024 and has matched on every close flyby since. The mission is in a new phase. It's no longer about getting closer, but about repeatedly sampling this incredible region as the sun moves through its 11-year cycle of activity. We are now watching our star from a vantage point once thought to be pure fantasy, gathering data that will keep scientists busy for decades. The probe will continue to fly through massive solar eruptions, measure the energetic particles that threaten our technology, and give us an up-close look at the engine that drives our entire solar system. Its legacy will be a new, more complete understanding of our star and how to better protect ourselves from its most violent mood swings. This is more than just a mission. It's a monument to human curiosity and our refusal to accept impossible as an answer. It's the story of a 60-year-old question and the audacious machine we built to find the answer. The Parker Solar Probe has taken us from a theoretical idea scribbled on a page to the very heart of our own star. If you found this journey to the sun as incredible as I did, be sure to subscribe for more stories from the frontiers of science. Thanks for watching.